For this question, you have a slope, and it's really important to set up the axes and to set up the forces and the diagram. So look closely at this diagram. What I did was drew the person sliding, and then the three forces acting on them are the force of gravity down, the normal force perpendicular, and the force of friction up the slope, because this person is sliding down the slope, down the slide, so the friction is opposing that motion and acting up the slide. So what I did here, the yellow lines are the axes, and so you can see they're rotated, so they're not vertical and horizontal, but they're perpendicular to the axis. The y is perpendicular to the axis, to the slide, I guess, and the x is parallel. Is parallel to the slide. The angle that the slide is inclined at is 28.1 degrees, and you have to do a little bit of geometry here. So if you imagine this, I can't really point, but this triangle is a right angled triangle. So if this is 28, if the original angle is 28.1, this angle in here is going to be 90 minus 28.1. And so then this angle in here is going to be back to 28.1 degrees. So make sure that you understand this part. Then what I did, where I got that angle was by drawing the components. FG is straight down, and the components FGY has to be parallel to the perpendicular. Parallel to the perpendicular, that sounds weird, but it has to be along the y-axis, and FGX has to be parallel to the slope. So this is a really important diagram to be able to figure out, and if you don't, you should come in and ask me questions. So once we've got our diagram set up, the first question asks us to find the force of kinetic friction. Kinetic friction has an equation, FF equals mu Fn, so I'm over here now, mu Fn. We know mu, but we don't know Fn. So how do we figure out Fn? Well, we look at our diagram. Fn is a force that acts perpendicular to the plane. So I'm only going to look at the perpendicular dimension. So in the perpendicular dimension, the person is not floating off the slope, they're not smashing into the slope, so their acceleration is 0, so their net force is going to equal 0. So perpendicular to the slide, F net equals 0. Okay, so then if that is true, the only two forces acting in the perpendicular direction is the normal force up and the force of gravity in the y. This orange vector, FGY, is opposing Fn. So you can see our equation, this one right here, is, well, let's actually look at this one. This one right here is saying that the normal force is not equal to Fg, but is equal to the y component of Fg. So how do we solve for Fg? Well, I did that over here, where I looked at the triangle and solved it. So if the angle is 28, if that angle is 28.1, then the FGY is the adjacent side, right? So then it's the relationship is going to be cos theta. So you can take a look at that triangle and see if that makes sense to you. So then FGY is equal to FG cos theta, and that equals to mg cos theta, because FG equals mg. So you can see here that FG equals mg. So plugging all that in, I get a FGY value of 530.79 newtons. And that I then plugged into my normal force. So now I know my normal force is 530.79 newtons. I go ahead and plug that into my original equation up here, right? And I did that down here, and I got 70.6. One thing I want to tell you is that when I do these numbers, I don't round from my calculator. I add extra digits so I don't end up with errors introduced by rounding. So that was part A. Part B asks us to find the acceleration. Now, if I look at my kinematic information, I know the distance it traveled. I know it starts from rest, but those are the only two things I know. So I don't have enough information to solve this through kinematics. So what I have to do is go back to my dynamics. So I'm going to analyze this now. Instead of parallel to the slide, I'm going to analyze it. Sorry, instead of perpendicular to the slide, I'll analyze it parallel to the slide. And in the parallel direction, it is accelerating. So F net equals ma. Ma equals the sum of the forces. In the x direction, what are the forces acting? Well, there's this green vector, FGX, acting down the slope, and there's the force of friction opposing it. So FGX minus FF. So I have this whole equation here, MA equals FGX minus FF. Rearrange it to solve for A. Plug in the values, and you get a value of acceleration that's 3.47 meters per second squared. And then part C is a straight up kinematics question. So we figured out the acceleration, we know the V, we figured out the acceleration, we know the V naught, and we know the delta X from the problem. We just choose the equation that doesn't have delta T in it, rearrange it, solve, and that's the answer.